Hi again, you guys. We're here to do some more algebra. Welcome. Hope everybody is doing well, and hopefully today will go fairly easily for you and be kind of a shorter explanation. So let's give it a try. So we're going to do section 10.7 on page 678. 10.7 on 678. So last section we learned about the quadratic equation or quadratic formula. I'm not going to sing it again. Okay. That is the quadratic formula or the quadratic equation, which we used last time. Remember, all the times that we are solving for these equations with the x squared, it's always getting us how many solutions there are, right? So if I graphed it, it would look like this, and the solutions would be here and here. Remember that? If it was up here, there would be no solution because it would never cross the x-axis, okay? And sometimes it's just one solution because it hits it only at its vertex, okay? Remember, we learned how to factor. Like when we got to factor, that was from last chapter, and got this, we knew the solutions would be 2 and 1, which means that it would hit the x-axis at 1 and 2. We've used completing the square to get our answer. We've used the square root button on our calculator to get the answer. We use the quadratic equation to get the answer. So we've done a lot of different things to get the answer. In this section, we're not actually going to be looking for the answers. What we're going to be doing is we're going to be seeing how many answers we're going to have. So the questions say how many solutions does it have, or how many x-intercepts does it have? Well, this would be 2. This would be 0 or no solution, right? No solution, 0 intercepts. This would be 1 solution, right? Because it just hits it in one place. So all we're looking for today is if there's 1, 2, or no solutions to these problems, not what the actual answers are, okay? And to do that, we're going to use part of the quadratic equation. Okay, so the part of the quadratic equation that we're going to use is called the discriminant. The discriminant is here. Just that part. Not the square root part at all. Just the part inside the square root, but we're not going to square root it at all. So we just plug those numbers into our calculator. We do that and we see what our results are. I have some written over here. If my answer is bigger than 0, if the answer I get when I do this right here is bigger than 0, I'm going to have 2 solutions. You don't have to tell me what they are. You just need to tell me that there's going to be 2 of them, okay? If I plug it in and my answer, when I do the discriminant, is 0, just the number 0, okay, it equals 0, you're going to have 1 solution. Again, you're not telling me what that answer actually is. You're just telling me, oh, there's going to be 1 answer to this problem, okay? And the last one is if the answer I get when I do this is less than 0, okay, then you're going to have no solution. Okay, it means it's going to be not touching the x-axis at all. Okay, so those are our little cues there. You can see them again on page 678 in the blue box if you need to review those in your book. Okay, so let's try an example of this and see what we can do. So remember in our equation, it's ax squared plus bx plus c. Okay, so those are the locations of each of the things in our equation. All right, so before we can start, we have to make sure it's all on one side, right? Just like usual. So let's look at example number 2. I want to start with example number 2 on 679. Our equation is 3x squared minus 7 equals 2x. Okay, so the first thing I want to do is, are they all on the same side? I don't know if you can still see that. Yep, all on the same side. Let's do that first. They're not, right? I need to move this 2x here, so I'm going to subtract 2x. And now I'm going to put it in order, 3x squared minus 2x minus 7 equals 0. Now are they all on the same side? They are all on the same side. So now we can go ahead and do our problem. All right. So remember, according to our little example here, our B is this number right here, right? Our A is this number, and our C is this number. Okay. So let's go ahead and put it into the discriminant, which remember is only this. Okay, so plug in. I'll put right here is what we're going to do next. We're going to plug it in, okay? So we're going to take our B. What's our B? Right here. -2 squared, B squared, minus 4 times A. What's our A? 3 times C. What's our C? Our C is -7. Remember, when we're doing the discriminant, we don't square root. We only do the part in the circle, okay? So let's plug that into our calculators. -2 squared is 4. Let's go ahead and do this. 12 times -7 would be -12 times -7, okay? So that would be a positive in the end, and you should get all done in your calculator. It says 88. Try that. Pause me and try that. If you don't get 88, work on it until you can get that correctly. It might just be a parenthesis situation here or here, okay? You should get 88. Now let's check. 88 is a positive number. So is that greater than 0? It is greater than 0. So how many answers am I going to have for this problem? 2. Again, you're not telling me what they are. You're just telling me that there's going to be 2 of them, okay? So you're going to answer it has 2 solutions. All right, that's all we're trying to figure out right now. Okay, so let's try example 3. Example 3 is exactly the same, only the directions say, find the number of x-intercepts. Well, remember when we graph something, the solutions are where it hits the x-axis, right? So the x-intercepts are the exact same thing as the solutions, okay? So we're going to do it exactly the same way. So let's try example number 3. Okay, we have y equals, they do that when they do x-intercepts, but we still do it the same way. X squared plus 5x plus 8. Step number 1 said, are they all on the same side? Let's look. Are they all on the same side? Yep. Do I really need this y here? You can get rid of it if that's confusing you. Don't worry about it. We don't really need that. Okay, remember this is my A. If there's nothing there, what should it be? A 1, good job. This is my B. As long as it's in order, you got to check to make sure it's in order first. And this is my C, okay? All right, so B squared. I always put things in parentheses just to make sure I'm getting everything taken care of. B is 5, okay, minus 4, that's always a 4, times A times C. A is 1, C is 8. Okay, so you apply that into your calculator. 25 minus 32, and we're going to get into a negative number. Okay, when you do this, the answer you should get is -7. Remember, we're not trying to find the solutions. We're just trying to figure out how many there would be. So if my answer is a negative number, I go back here to my little code thing here. If my answer bigger than 0, nope. Is it equal to 0? Nope. Is it less than 0? Yes. My answer, which is -7 when I did the discriminant, is less than 0. So when your answer is less than 0, it means you have no solution. So my answer here would be no solution. Look at the graph that they did there in their example. They graphed it on a graphing calculator. Does it look like it's ever going to hit the x-axis? Nope. So we did it correctly. No solution. Questions? Okay. Example number 4 is just a quick word problem. I'll just look at it with you real quick. I don't need to spend too much time doing it. They gave you the quadratic, or they gave you the formula in the directions there. Then they told you at what point does the water reach a height of 50 feet. So I'm going to go ahead and put the 50 as what it equals. Then I'll move it, and then I'll just do the discriminant just like always, okay? Or solve. This one might be solved because they want to know how far from the north shore is the water. Okay, so you're just going to solve, okay? Using this quadratic equation. All right, Good luck. Please, I haven't heard from many of you about math, so please let me know if you're confused and you're not understanding it. I'm super happy to FaceTime or whatever we need to do. Just let me know, okay? All right, we'll talk to you guys later.